So I would like to welcome all of you and thank all the attendees who are with us today, this morning, also for your interest in discovering something more about BioDT and all the research infrastructures that cooperate with us. My name is Rita Giuffrida. I am the communication manager of BioDT, and today I'm very pleased to moderate this final webinar of BioDT. For people that have already followed us in the last years, you know that BioDT started its journey 3 years ago, and that we also finalized our activities, and we also officially celebrated the end of the project last month during an official event in Rome. You can also discover and learn something more about this in our official website. But today, as the project is gonna end soon, and one of the core activities that we have performed is related to the interaction between data and biodiversity data and the research infrastructures, we decided really to focus the webinar on this. So as you know, the webinar is starting now and it will run until 11 a.m. Central European Time. Today we are expecting online 60 people that are mostly coming from the research environment, but also from research infrastructures. We also have people coming from the industrial environment and policymakers. And the nice thing that we notice is that these people are coming from more than 20 countries around the world. We also saw quite a lot of people that were coming mostly from, we were expecting quite a lot of people from Europe and also from Africa. We hope that you will really learn something more today. And with this, I will also introduce to you officially the agenda for today. At the very beginning, you got a welcome from me, following which you can really discover and learn something more about the research infrastructure. In particular, in BioDT, we are cooperating with 4 that are GBIF, eLTER, DiSSCo, and LifeWatch ERIC. So the first introduction will be given by our colleague Dmitry Schigel. Then there will be Christoph Wohner from eLTER, followed by Sharif Islam from DiSSCo and Joaquin Lopez Lerida from LifeWatch ERIC. At the very end of this webinar, you can also have the opportunity to ask questions to our attendees. So feel free all the time to use our Q&A or our chat here on Zoom. And with this, I will officially start the webinar. Before presenting to you GBIF, I would like just to share with you that unfortunately Dmitry had a clash this morning, so he could not be physically with us, but he recorded a presentation about GBIF that I will show now online. So just give me a moment because I will just switch my screen and start the presentation. So enjoy the first presentation of GBIF, and following this, I will pass the floor to Christoph.
This is a video presentation from the Global Biodiversity Information Facility. GBIF has become a partner of the Biodiversity Digital Twin project, BioDT, as a research data infrastructure, and this presentation will illuminate key achievements and progress lines at GBIF that were directly influenced by the BioDT project work. When we present on what GBIF is and how it works, we often start from stressing the role of biodiversity data for science, policy, and decision-making. And to do that, GBIF works to mobilize data, skills, and technologies. GBIF works on the basis of free and open access to data to address biodiversity loss and sustainable development. These activities unite almost 2,500 organizations from most of the countries in the world, making more than 3 billion records available through gbif.org and over 50 hosted portals. These data are accessed broadly at the rate of more than 200 billion records a month. The infrastructure is financially supported by 64 participant countries, and we hope that formal country participation in GBIF will grow. The GBIF work, funded by the participant countries, is further supported through project involvements, including BioDT. In GBIF, data plays a central role. Data is generated by the range of organizations and technology types, at the left of the slide. Data transition to data publishing, indexing, and access in the center, to data application and use on the right. In practice, data users are very often data producers, so the schema shown here has an invisible loop connecting data use back with data generation. For the prototype digital twins, the availability of fair data sources with a range of data access solutions, including API, is very important. GBIF's power is in the breadth of available data, whereas other RIs are able to handle data complexity and combination of biodiversity and of environmental data. For example, one of the prototype digital twins, the phylogenetic diversity twin, actually hosted by GBIF, is combining GBIF-mediated occurrence data with phylogenetic trees and enabling modeling, visualizations, and metrics of biodiversity, taking into account evolutionary relationships of species together with their detections in space and time. For every prototype digital twin, data is an essential and a dynamic foundation that enables production of computationally heavy and fast metrics and predictions of world's biodiversity. DNA-derived data play an increasingly important role in detection, identification, and quantification of life on Earth. The data standards have evolved to allow the data flows between the molecular data and repositories and the biodiversity data discovery platforms such as GBIF that happened before BioDT. To address the need to process the eDNA and metabarcoding data from the formats native to the data-producing community for publication through GBIF, the new metabarcoding data toolkit has been built to enable DNA data flows. This toolkit is available across GBIF network to allow smooth processing of metabarcoding and eDNA data for discoverability through GBIF. This way, DNA detections become discoverable, for example, through spatial or taxonomic queries alongside the morphologically detected biodiversity, for example, next to the museum specimen data, citizen science observations, as well as systematic surveys and observations. GBIF's ability to index an increasing variety of biodiversity data has been growing and has generated the need to evolve the data model. Richer data were needed for some of the prototype digital twins, and richer data model developed with the BioDT needs in mind make GBIF ERI more readily for the needs and challenges in the future. A broader and broader variety of parameters and data elements are being collected following evolution of scientific methodology and technology. Some of the long-term projects generate datasets that mix location, media, DNA, protocol, acoustic, video data, storage details, and many other data types. On the basis of this work, GBIF will be releasing a Darwin Core data package, a new, richer, more accommodating format that captures key agents, processes, and attributes that needs to be documented to efficiently interpret and to apply complex ecological data. Which brings me to the next aspect of the data complexity. While data models evolution allows for better connecting across data types, development of data standard provides the terms for tabulating complex datasets. GBIF has started from museum-based data. It grew to provide access to the citizen science data and now increasingly links all that with DNA-derived evidence. Until recently, existing standards did not allow to capture sampling effort, taxonomic targets, protocols, and other key aspects from systematic survey and monitoring data. During the BioDT timeline, TADWIC, the international standards community maintaining the Darwin Core standard, has ratified the Humboldt extension to Darwin Core. The Humboldt extension work changes the data flows that are discoverable through GBIF. It allows to publish presence data, but also to infer absences and to document abundance and richness parameters, to document biodiversity change through time, including in the context of monitoring invasions and conservation actions. BioDT project work supported production of the Humboldt Extension Quick Start Guide, which will be followed by the more detailed guide. Availability of the guidelines and of the expertise, and also the inside project partnership, resulted in exploration and testing the data display from 15 eLTER datasets used in the BioDT grassland prototype digital twin to be published through GBIF. This RI-to-RI work within the BioDT project has a great potential to continue in the project afterlife. In other words, this larger-scale data sharing development allowed for mapping eLTER data model to Darwin Core and to Humboldt extension to refine data publishing processes between the research infrastructures. These are a few examples of transformational and of lasting changes that BioDT project had onto the GBIF research and data infrastructure. As this is one of the closing events of the project, I would like to thank all the project partners, organizational and individual, for the great and educational time together. We're of course grateful to the Horizon program for providing the financial opportunity to prototype biodiversity digital twin and to improve data processes around them. I hope this presentation has helped to illuminate these sometimes not very visible yet very important improvements. Thank you very much for your attention.
So I hope that you found the presentation insightful, especially if it was the first time that you were hearing about GBIF. That is, as I was mentioning at the very beginning, but as also Dmitry mentioned, it is one of the research infrastructure that is populating the BioDT digital twin. Actually, in this presentation, we also had a connection with eLTER. So then I will pass the floor now to Christoph. Then instead will provide an overview about eLTER and in particular how this research infrastructure has cooperated with BioDT. Over to you, Christoph. Thank you.
Hello, everyone. I hope you can see my screen. My name is Christoph Wohner. I am presenting the eLTER work and the lessons learned in the BioDT project for the eLTER consortium. I'm already using the word eLTER consortium, and I'm confronting you with an abundance of acronyms on my first slide. There's not one eLTER organization in BioDT. Instead, we were a consortium of a number of organizations, namely the Center for Ecology and Hydrology in the United Kingdom, CSC in Finland, the Environment Agency in Austria, UFZ in Germany, and the University of Helsinki in Finland. What you can see here are the names of my colleagues that provided content for the presentation. In reality, there are more people behind this, and I'm just here on behalf of all of them presenting eLTER and our lessons learned. What is eLTER? Unfortunately, I don't have a lot of time for this presentation, so I can only very briefly explain this to you. The eLTER is an integrated European long-term ecosystem, critical zone, and socio-ecological research infrastructure. And that in itself is already a very challenging thing to say. It follows a whole systems approach and does research on the atmosphere, social and economic sphere, biosphere, hydrosphere, and geosphere, and tries to connect all of those research into providing a holistic overview of the state and developments and trends in our ecosystems. If you want to know more about this, I recommend that you go to the eLTER website, elteri.eu, and check out the wealth of promotional material that we have over there, and just dive into all of the things that are being done in eLTER and all of the data sets that we have already produced and also provided for BioDT. One of the major things that eLTER partners have done in BioDT was the Cultural Ecosystem Services, PDT, which supports the use, planning, and management of cultural ecosystem services, focused on recreation by enabling people to select areas to visit depending on the personal preferences. I recommend that you just go to the BioDT Shiny app and just click your way through it. This DT consists of two different parts, really. It consists of a recreation potential model that is used to quantify the cultural ecosystem services of the physical landscape. Basically, if you take a walk through a very particular part of the United Kingdom, the Cairngorms National Park, how does it feel? And also a species distribution models to quantify the biotic component. So there was modeling work done on the abundance of certain species. Species distribution models were validated using independent vegetation survey data by the UK Environmental Change Network, which is part of the eLTER network. The dataset recorded the presence and the absence of vascular plants, bryophytes, and lichen species across multiple plots in the eLTER site Cairngorms. This was not used to train the SDMs, ensuring an unbiased evaluation. Like I said, I don't have a lot of time. I just recommend that you use the outputs of this project and click your way through it and see what's been done. What we've also done is that we've provided eLTER data for the grasslands dynamics digital twin. We mobilized historical, previously unpublished or already published, partially published in different form from eLTER sites via data call in the eLTER community, which was done in work package 4. This data was used to calibrate the model used in the grasslands dynamics PDT. The data sets were published using the following the FAIR guidelines that were developed in work package 5. That means we did additional quality assurance as required by the PDT. We uploaded the data sets if they hadn't been uploaded before to B2Share. It means we issued TOIs for whole data sets and PIDs for single files. They were licensed under open data licenses. We generated and included RO crate files as defined by work package 5. And all of those data sets were also indexed in the eLTER digital asset register. Those things mean that the datasets can also be reused by others, and they can also be reused in the scope of other projects. So it's not just exclusively for BioDT, but it's open for the public, really, not just scientists, but for everyone who's interested in using them. These datasets were also the basis for the eLTER GBIF mapping that was already mentioned in the previous presentation. What was the data sharing pilot between eLTER and GBIF? eLTER sites collect, among many things, following the whole ecosystems approach. They collect biodiversity observation data, which is aligned with other environmental measurements. GBIF is a global aggregator for biodiversity data, so it's a very natural step to try to combine those two things. GBIF uses common data standards like Darwin Core and its extensions and the ecological metadata language. So what we did is that we did a data integration between the eLTER and GBIF data. We mapped the existing data sets, most notably the ones that we mobilized for the grasslands PDT. And we developed a mapping that looks like this, that we're going to use to provide eLTER data to GBIF. This was done by my colleague Sarah Venier at my agency, at the Environment Agency Austria, as well as Hanna Koivula at CSC, together with colleagues from GBIF, most notably Kate Ingeloff. In addition to that, applications were developed, most notably for the real-time bird monitoring PDT, as well as the invasive alien species PDT. That was done by my colleague Alan Suse from the University of Helsinki. We provided input for the publications, most notably those were the publications of the PDTs that we were providing contact for, as well as the overarching PDTs, as well as the overarching publications for the BioDT project as a whole, as well as the development of the Shiny apps, as well as graphical user interfaces. What were the aspects of our work that are sustainable beyond the scope of BioDT. eLTER data, eLTER input was used to improve existing models and input data sets. So this was mostly for the cultural ecosystem services and grassland dynamics PDT. We publish data sets on B2Share, and we will publish them in GBIF as well, ensuring a maximum uptake of those publications. We developed publication workflows that can and will be reused for future eLTER-related projects, and the data sets can also be reused outside the scope of eLTER. So even if you're not associated with eLTER, the data sets that have been published, they are openly available under an open data license, so you can just take them and use them, and the documentation that's available online should be sufficient, but people just understand the content and reuse them. Additionally, we provided input for the Fairness Work Package, Work Package 5, and in return applied the developed best practices in this work package to the eLTER data repositories. We have planned an implementation of RO crates beyond the scope of BioDT, which we also want to use in other projects. All in all, this increases the fairness of the eLTER data infrastructure and the data sets that we produce, as well as the uptake of eLTER data. What are the lessons learned? So what did we learn in the scope of BioDT in the past 3 years? What we've really noticed is that modelers have needs that are sometimes hard to meet with already published data products. Something that I've also encountered in the other projects is that a key performance indicator in projects is oftentimes the number of data sets and data points that were published, but not quality. This oftentimes results in quantity over quality. So it's all about publishing data sets. It's not so much about the quality of the published data sets. Now, here's the catch. It's the devil lies in the detail, right? Low quality data sets can actually deteriorate data flows and model results. So if you have a model and it works fine and you feed it with flawed, incorrect, broken data sets, it can actually make the output of the model worse. So what's needed is more quality assurance in the initial data publication process. This includes both having standard protocols and, second part is also very important, actually following those standard protocols. What we noticed in BioDT, again, we already noticed this also in other projects, is that there are simply mistakes in published data sets. It's a reality, it's something that happens. However, you oftentimes only notice those mistakes when you actually work with the published data sets. I had a very negative and pessimistic approach about this and said, oh, this is just terrible because you have the published data sets, and how do you deal with that? One of my colleagues had a far more optimistic and positive outlook on this, and she said, well, actually, this can be seen as a form of peer review. This is something that just increases the quality of data sets. It shows that it's being used, and it can also lead to improvements of existing data sets. Nevertheless, corrections were necessary. We did those corrections, and they required manual work, and manual work already implies that it hinders automation. The problem about the necessary corrections were that missing information was usually hard to get, especially with historical data sets, and needed and I really should have underlined this part, voluntary unpaid cooperation of experts. So basically, we were working with data sets that had already been published in some other form. Whenever we discovered flaws that were too big to ignore, we actually had to get in touch with the original authors of the datasets and ask for their input. Now, those people were usually not part of the BioDT project, meaning they didn't have time or funding to work on this. Because they are lovely people that really want to progress science, they helped us, but we were reliant on voluntary unpaid work of colleagues. And this is something that can happen, but you can't rely on it. And it's one of the aspects that are very difficult about working with in situ data. Overall, to sum it up in one key statement, bringing modelers and data providers in the form of RIs closer together benefits both sides because it provides data for the modelers, but it also provides useful peer review and feedback for the data sets that are produced by RIs. And I'm concluding with that. I thank all of you on behalf of the eLTER team. Thank you for listening, and thank you BioDT for providing us with all of those wonderful opportunities to work with you.
Thank you, Christoph. And if I might also make a comment about the last slide, about the lessons learned that you made, you really pointed out a very important topic, especially for projects that work with a lot of different data, because having high quality data is always a difficult thing to do. As I mean, you were mentioning all the difficulties that you mentioned. Maybe we can also discuss this a little bit more in details during the Q&A. But now, as you were also talking about fair data and also see the importance of really improving the quality of the overall data sets of eLTER, I will pass the floor to Sharif, who will instead provide an overview of DiSSCo and can also explain what fair data is. So, Sharif, over to you.
Yes, thank you everyone for joining and thank you for organizing this. My name is Sharif and I will be talking about distributed system of scientific collections, which is a research infrastructure participated in BioDT along with eLTER, LifeWatch and GBIF. As mentioned, I will briefly highlight the contribution we made through the idea of FAIR and some of the things already brought up by Dmitry and Christoph, and also some lessons learned. Just a quick introduction, if you're not familiar, FAIR stands for Findable, Accessible, Interoperable, and Reusable. It's a sort of a best practice way of understanding scientific data. In this project, we particularly focused on how to improve interoperability. And this means, for example, if you have a data set model that works in one project or one system, how do we move that and make sure that it works in different system? You already heard about data publishing and reusability. How do we make sure all of these data are available? And of course, each of these organizations and infrastructures have their own design and own semantic and other information. How do we do that and align that? So these are kind of the task that we worked. And the reason DiSSCo got involved is that DiSSCo had a vision of some of this FAIR implementation within our project. And then we thought this would also be a good contribution within the biodiversity, and in particular, how different infrastructures are working together. So we had this grand vision in the beginning of the project. So in the ideal world, imagine all of these different infrastructures and all the other data sources are coming together, and they are already providing FAIR digital objects. So this could be data, software, models. That often means that they have persistent identifiers, they have metadata standards, and in the middle, you have applications, systems, platforms, digital twins that coming together because you need to bring them together to make it work. And I will show you at the end, one of the way we implemented it is through a metadata integration using a framework called AutoCrate, and that's one way to achieve it. Of course, there's still a lot of work to do, but this is kind of like the ideal world. We are working together to bring all of these things together to allow digital twin and even other applications to perform. A brief introduction to DiSSCo. As I mentioned, we are a research infrastructure working towards digitally unifying natural science collections in Europe. And this means natural history museums, herbarium, and other research collections. And currently we're working with more than 200 organizations across 23 countries to sort of create this coordinated way of curating these physical objects and making digitization and also policy and community of practices. And the main idea of this research infrastructure model, as also you heard from GBIF and eLTER, is to create this integration. So of course, a lot of our data and organization are scattered. Sort of in the old model, people visit these things separately. There's not much communication between organizations. So we're trying to kind of fix that in this integrated model to save money and also give proper access and quicker access and optimize access to FAIR data as well. So currently we're in our preparation and transition phase. So we will be working towards a legal entity similar to eLTER and LifeWatch called ERIC, probably in a year or so. So we have some operational services, but they're not in a fully production state. But we are slowly going there. And some of the experience we learned from BioDT about fair implementation metadata are also helping us to refine some of our fair thinking as well. And quick reminder why we're interested in all the collection and specimens in Europe and also, globally. Because a lot of the specimens are stored in Europe, are coming from the rest of the world. So it also has global implications. So of course, taxonomy and systematics are important, but ecology, genomics, and biodiversity conservation. So all the specimen data, both physically and digitally, provides a lot of different inputs. And this also, as you understand, that digital twin needs all of this input with combination of other things. And one of the design choice we had in DiSSCo is thinking about these single objects also as a digital twin. So imagine, this specimen of a bug that's sitting in a museum. We digitize it. So typically you think of it as some data and pictures, but we want this digital specimen to be much more dynamic, kind of like an entity on its own, doing things, working with AI, and of course, becoming fair. So this idea of digital twin from a single specimen kind of gave us also the opportunity to contribute to much more complicated idea of digital twins, how to combine different things. So here also you can see some interaction with DiSSCo and GBIF, how we envision DiSSCo sitting as a platform. So on the left-hand side, we have all the museum collection management systems. So this is very similar to a library catalogs. So they're kind of our main source. They're coming from all sorts of different collection activities. And then using some of the already standards that out there like Darwin Core and EML, we're trying to harmonize them because each of these collection management systems have their own way of publishing this data and provide some identifiers, tracking provenance, and provide annotation and other tools. And then when these data go to the aggregators and repositories, they're already in a much better shape. So that's kind of like the idea of DiSSCo as a platform coming in together. And you can find out more on our website as well. And this is just a quick overview of some of the things we did in this FAIR work package, also helping some of our prototype digital twins. This idea of fair digital objects, again, looking into specific metadata, both for data software models, what is it, who made it, what's the license, things like that. So very basic descriptions. We also worked a lot on semantic mappings. For example, somebody talking about location, somebody talking about habitat, do they mean the same thing or not? So those also need some mapping work, and of course, quality. You also heard earlier, that's important. How do we understand that? And then again, to remind you, all of these things matters because they all come together to build a digital twin. So if one of these kind of not working, the downstream digital twin will have some impact as well. That's why the workflow is also important, where some of the scripts and steps are bundled together in a fair manner. So just to give you an example, some of the metadata profile that we talked about. So we published some of these things, and also some of these are being used as well in the prototype twins. So some of our very, as I said, basic terms and definition. This could be shared by all sorts of different use cases. And then if you have much more rich metadata for your use case, you can also extend that to describe those things. And I will give an example of how we did that with this ARO-Crate JSON LD specification. Again, just a little bit more detail, what kind of metadata could be collecting. And again, our experience working with other biodiversity data and specimen data also helped us to think about these things as an individual unit and how they come together, both from the model and the dataset side. And for the workflow, we also had some help from University of Manchester and some of the work coming from EOS that also helped us to reuse existing work. So this is one example. So this grassland dataset and model, you already heard about it. So in the picture that I showed first, where everything is coming together, so this is our one example of this metadata file that can describe. So for example, you have this model. We want to know who was responsible for creating this model. Here we know there's 2 researchers were involved. What kind of programming language was there, where I can find the code, and what data is associated with this model, either for training or input or output, things like that. So these data sets, in this example, they're coming from eLTER, but this could come from GBIF. the tools can come from LifeWatch. All of these things could be captured here. And then there could be some core metadata that we could say that in this RO-Crate framework, these are mandatory attributes, for example, license or PID, things like that. So in a way, this vision of bringing everything together in this box to help make a digital twin is one way we kind of accomplished it. But again, there's a lot still to do because all of these things are coming from a variety of different infrastructures. So they all have different ways of describing things. So we have to align them. And in the future, looking, one of the prototype digital twins were piloted in some other projects. So we had one called the crop wild relative, where some of the data were used to understand, for example, trait information and things like that. So in this image, you see this is a herbarium image where you can actually run AI model to get trait information or information about the size of the leaves or organ and things like that. And this has a very high potential benefit for cross-domain data integration, DNA and traits, and providing that as an input with different projects, including other digital twins as well. So this is one of the pilot we worked on. And here's a little bit also more technical information, how it will fit into sort of this broader initiative called Destination Earth, which is also aiming to create a much more bigger digital twin model of the whole Earth, where biodiversity and other digital twin will come in as components. So in this example, this could be a biodiversity and agriculture related digital twin that will provide information. And again, you can see some of the components I mentioned already. There's different types of data coming in from GBIF, from DiSSCo, and also from climate related data. The workflow basically is your code and environment that captures together. If you want to grab this and say, okay, I want to run this in my environment, this is where it comes in. And of course, all of this metadata about the code provenance and output are also important within FAIR. So this is kind of something we will be still improving on based on our experience in BioDT. So yeah, I want to thank the BioDT project and some of my colleagues to help with this presentation, also other work. And thanks again for your attention and interest in this.
Thank you, Sharif. I would like also to remark that actually Sharif also mentioned at the very end that the team has really done a lot of work also to integrate this data into Destination Earth. And as I mentioned also at the very beginning of this webinar, we have also presented the main achievements of BioDT during the final event that we had last month. So but I will also share the link very soon in the chat. So in case you are interested in understanding a little bit more how BioDT is also cooperating with this big initiative, you can find more information online. With this, as we were also moving towards the destiny and the let's say a little bit the work that BioDT is gonna do also after the end of its life. I will pass the floor to Joaquin, who instead will provide an overview of LifeWatch ERIC.
Thank you, Rita. Welcome to all. I'm going to share my screen. Wait a moment.
Actually, something that I did not mention is that, let's say, the connection between, we actually left LifeWatch ERIC to be the last one because they will have quite a lot of interesting updates about the platform of BioDT and how it can be also used in the future.
Exactly. I will. Can you see the presentation? Yeah.
Yes, we can.
Yeah. Okay. Yes, I will introduce you the Shiny app, and in fact, I will provide you after the URL where you can see some of the achievement of the project. First of all, let me introduce, if you don't know LifeWatch ERIC, we are an European e-science research infrastructure. We are an ERIC, and we provide basically digital tools, services, and virtual research environment to support the work of scientific policymakers and environmental managers to understand and preserve biodiversity. We integrate data from multiple sources, and we enable advanced modeling, analysis, and visualization. So we we're playing a key role in addressing environmental challenges, fostering scientific collaboration, and promoting sustainable management of natural resources across Europe and we hope beyond. As you can see, we are our statutory and ICT infrastructure are in Spain, in Seville, and then we have a service center in Italy, in Lecce, and in Amsterdam, in Netherlands. We have the Virtuous Laboratories and Innovation Center, and also we have different nodes, as you can see, in Portugal, Belgium, Slovenia, Bulgaria, and Greece, and other countries that are coming. Our vision, as I have told you, is to become a research infrastructure to provide access to the world biodiversity content, service, and community by providing tools to the scientific community and deliver the European state-of-art science research infrastructure on biodiversity and ecosystem. We provide a lot of different tools through different portals, mainly that you can access from LifeWatch.eu. And in the scope of this project of BioDT, we have done several tasks, but mainly we have developed, we have contributed to the development, as Sharif has been speaking before, the Shiny app, whose mission is to provide all the tools and the access to the prototype digital twin develops. That is the URL, but I will provide you later. And I will show you. I will show you now the URL and the different access that are available now, because during these months we are going to be adding new prototypes. But basically, the characteristic of this integration, you can see a small view of the integration done, but there are only nodes and different machines that we have been using for the integration. But we have deployed this Shiny app via Docker, and we have orchestrated it with Kubernetes, all inside the LifeWatch ERIC infrastructure. We have provided an interface to execute all the federal models we have been speaking about before. And we have integrated and federated storage system with Lexi using protocol S3 with that. There is an AAI-based authentication using SANL with is federated with EOS, and we have made a workflow engine integration to communicate all the workflow execution through different APIs to provide the execution of all the workflow. At the end, the result is this is the access to the prototype digital twin that you can execute. I will show you now what PDTs are available now. We have 10 PDTs, but now there are 3 of them available that you can execute, you can try, and you can test. I will show you now some of them. So the 3 that are available are the Honeybee prototype, which is built on the Beehive model. It's a simulation framework for honeybee colony dynamics. You can enable different scenarios by seeing in the analysis of the colony health under varying conditions that you can manage and you can change. I will show you now. As you can see, it integrates different floral resources from data from high resolution land cover maps. I will show you now how you can manage this and how can you execute. This is the first one that we provide about through this portal. Then we are providing now the grassland PDT, which is a grassland dynamic model across European sites, simulating above ground biomass, yield, and plant functional group composition. And the third one we are providing is the cultural ecosystem services that applies, as you can see, a spatial regression model to evaluate landscape suitability for cultural service, like tourism, leisure, and aesthetic appreciation. All these PDTs and other ones are available. Sorry.
Okay, I believe that you stopped sharing your screen.
Yes, because I want to show you now briefly wait a moment. I'm going to share
Sure.
it again.
Okay.
Now,
Yes, we can see your screen. Yes.
okay, this is the URL where you can access the different PDTs. As I have told you before, honeybee cultural ecosystem and the grassland as they were available, and you can access them. For example, here you have the honeybees. We are accessing now. It's loading the data. You have here the PDT. This is very easy. Here you have all the simulation parameters that we have been integrating. You have to choose here in what part you want to run the simulation, and then you can run the simulation. It takes 2 to 4 minutes, and in some cases, takes even more. So I'm going, but then if you execute, then I have executed before. You will have here the results, and even you can download the results in plot data and Excel file, and you can use the result for whatever. This is one of them, one of the PDTs available. I'm not going to execute any of them, but you have here you can access also the cultural ecosystem one, where I'm running now the simulation, and the grassland also. I will provide you now the URL so that you can try it. And in the coming months, we are going to be adding the other PDTs to this website, so that you will be able to access it from this URL, from the BioDT URL websites also, and of course from LifeWatch services. Okay. Here you have the PDTs. I stop here my presentation and open to questions from you. Thank you very much.
Thank you, Joaquin. And I would like also thank you for providing this overview. So for all the attendees that have never tried the BioDT platform, you know now that it is open to everyone. You can also test it for free and also perform your analysis. So yeah, Joaquin will also share very soon the link here in the chat, so you can all try and test it. I was also looking now if we had any questions from the audience, but I could not find any. But as we had also a very interesting discussion before, maybe as we also have the last 10 minutes before the end of the webinar, I would like also to ask a very last question to all our partners. And in particular, let's say at the very beginning, maybe Christoph, I will start from you, because one of the points that you raised also in your presentation was about the lessons learned, let's say, and let's say the issues that eLTER face, but also how you try to overcome it. And do you think that these lessons learned will be useful also for in a long-term let's say perspective, especially for example, eLTER would like to continue provide data in an infrastructure such as BioDT?
Yeah, I mean, of course, I think there's a use beyond the BioDT project. I think it's very important to just know for scientists what they are dealing with in terms of data, and it's especially with in situ data, you shouldn't assume it's perfect. I think especially if your background is maybe more in remote sensing, they're used to like very shiny, perfect remote sensing data products where you have perfect documentation on the methodology. And then oftentimes researchers try to apply that to in situ data as well. And it's just a very different type of data set with its own upsides and downsides. And I think it's very important to like just raise the awareness. And it's also something that I encounter very often in the in such research projects that depending on the background of a person, they might have expectations that are maybe a little off sometimes when it comes to in situ data. So in terms of awareness building, I think it's great. For us also, it's just good to get feedback, to have people work with data, because the way some research projects are structured is it's all about publishing the data, right? It's not so much about really using it, right? It's you publish it, people include it in applications, but the actual breaking them down and really meticulous work where you really try to like see and work with it and do evaluations, and then you realize where things went wrong. Because if we receive this kind of feedback, of course we try to correct and improve the data sets, but for us it's also lessons learned in terms of how our protocols are set up. Because we have protocols, we say, oh, you should measure this and that in a very particular way, or we have specifications on data products and how it should be structured. And I will very frankly say these are not perfect. And the more they are used by people, the more feedback we receive, the more we can incorporate that feedback, and which leads to new versions of specifications that are hopefully better than the previous ones.
Interesting. Thank you, Christoph. And was actually very useful feedback. And maybe, Sharif, maybe I would like also to ask you a question, because providing feedback is important, but I believe that also providing training resources can also improve the quality of data. Can you provide maybe a perspective from DiSSCo and on
Yes,
this?
yeah, I think earlier we talked about this voluntary labor. So a lot of these things are still not automated. So we still need to spend a lot of time cleaning up data, understanding the metadata and description, things like that. So often I think we don't get direct funding for some of this work. So I think each organization and the funding project probably need to be a little bit more aware that there's all this extra work and support that's needed. So we need to raise some awareness. And then also in this project, we brought together different modelers, different experts from ecology. They all have different levels of understanding of data usage and fair and open science. So that also was, I think, a good learning experience for us to how to bring domain experts, but also find these common challenges and things like that. So yeah, training is important. So that also to remember that both fair and digital twin are not just magical things that will automatically work. I think all of these background things I think is important, and that was probably one of the biggest lessons we learned. That yeah, it's a nice framework, but a lot of this background work need to be supported.
Thank you. Do you know, let's say, in addition to the presentation that you have made, can you share maybe also some additional links where people could find any resources useful in
Yes.
terms of? Okay, thank you. Maybe Sharif, you can share it in the chat, and then we can make it available also online. Actually, we got also a question from Prashid, and I will read it out loud, and he asks, how do digital twins benefit from a metadata template aligned with FAIR principles? I don't know, maybe Sharif, you are the best person to reply.
Yeah, so I think the template is, again, as I was mentioning, that what we try to do is that we try to think about what are the common mandatory attributes that can apply in multiple use cases. For example, we had one use case for honeybees, we had one for grassland, one for crop wild relatives. So they're all very different, but if you can identify a common elements that can create a common templates that we can say like, okay, for all the digital twins, grab this template and apply it. And then, everybody have other extra metadata and data, then you can extend that. So that way, I think we can reuse some of these templates and make it easier for people to say like, okay, I'm going to use this template for my digital twin, and that we don't have to think about it. So we can make this a little bit more easier. So that's one way template can help with fair implementation. But of course, we need to maintain this template. We need to make sure they're workable. So there's some work needed. But when it's ready, all of this different system can apply them very easily.
Perfect, thank you. Maybe I will ask another question to Joaquin instead. And maybe I will also go back a little bit to the presentation that you have made, that is about the long-term sustainability of BioDT. So from a LifeWatch ERIC perspective, what do you think would be the let's say benefits also of hosting the platform and cooperating with the other research infrastructures?
Yes, Rita, about the long-term sustainability, first of all, we are in LifeWatch. We are absolutely compromised with the long-term sustainability of the project, of course. And one of the key strategies we are implementing is the stable and secure hosting of these PDTs, and I have showed you develop as part of the project. We are integrating in our infrastructure, make them accessible. We are establishing as specifically as a reliable and scalable platform inside LifeWatch, because this will be important. By hosting the prototypes, I think that we are ensuring not only their continuous availability, of course, beyond the project lifetime, but also the maintaining, the version control, the potential for further development, integration. We have been speaking about Destination Earth, for example, so the integration in other broader projects, workflows, even research services. I think that, in fact, this approach is absolutely aligned with the LifeWatch ERIC mission to support the long-term accessibility and usability of any digital tools. Mainly, we have a big mainstream about the my.lifewatch.eu website that we are supporting all the tools. And additionally, the technical and data management teams are already working on harmonizing the PDTs and integrating the new PDTs that will be coming in the following months, and including in the metadata catalog, make them accessible through the APIs. And also, I'm going to give the floor to Christoph, to our CEO, that also want to add something. Christoph, the floor is yours.
Yeah, thanks, Joaquin and Rita and colleagues. I just wanted to add a single thing here. There is some need, in some of the prototype PDTs for HPC resources, or even some systems that include GPUs, etc. So LifeWatch can also guarantee the provision of this, but not at the scale at which we had them in during the lifetime of the project. Lumi was there, the major provider of these big resources. We can make this provision through our data center, but we cannot compare ourselves with Lumi or with Amazon or with Google. So I just wanted to make sure that along with the maintenance and the upgrade of the research products there, we're going to guarantee some support with computing resources behind. Thank you.
Thank you, Christos, also for making it the last point, let's say, also about this, and make also this clarification to all. Actually, now it is also 11 a.m., so we are really on time. And I would like to thank again all the attendees and speakers for joining our webinar, as also for all the other webinars. This will be available online, and we will also make all the slides available. So if you would like also to rewatch them, feel free to visit our website and also our YouTube channel. In the presentations, there are also the contacts of the presenters. So if you have also specific questions for them, and also for Dmitry, who unfortunately could not be with us today, you can also contact them via email. So thanks again, everyone, and I wish all of you a pleasant rest of the day. Bye-bye.